Hello, this is going to be section 13.1. Because the section's actually relatively long, I think I'm going to break this down into 3 videos so you can sit down, watch part of it, complete the homework, come back, watch another part, complete the homework, and so on for this section. Chapter 13 deals with counting, probability. We're going to be doing some combinations later in the chapter and some permutations. But right now we're just going to deal with the idea of probability when it comes to counting. So we have to put some definitions. You've seen some of these definitions before, but you may or may not remember them. Determining the probability of some event is a useful and interesting skill. In order to calculate probabilities, we first need to be able to count, and in mathematics we often use set notation to help with this process. So when you're comparing two sets are equal if they contain the exact same elements. B, A, is a subset of B if all of the elements in A are also in B. A is considered a proper subset of B if A is not equal to B, but all of the elements of A are in B. So A is a proper subset of B. A is a subset of B, but A is not equal to B. So therefore, A is a proper subset of B. The empty set is a subset of every set. I think you saw this in Advanced Algebra 2. The empty set is a subset of every set. You can write that as the null set. So when we look at number 2, it says, what are all the subsets of the set that contains the elements 2, 4, and 6? So from above, we know that the first one will be the empty set or the null set, the subset that contains just 2, just 4, and just 6. So the individuals, then the combinations 2 and 4, 2 and 6, and 4 and 6. And finally, the set is a subset of itself. So the subset 2, 4, 6. We know if A is a set with n elements, A has 2 to the n subsets. That's just a way to check and make sure you have all of the subsets. So for example, A has n3 elements. So 2 to the third is 8, and it has 8 subsets. A with an upside down U is the intersection. So A intersect B. This is the intersection of A and B. That is those elements contained in both sets. Number 4 is the union. So A joined with B, the union of A and B. And that's a combination of all of the elements in both sets. Okay, number 5 says let set A be the numbers, the elements 1, 2, and 3, set B 2, 4, and 6, and set C 3 and 6. So the union of A and B will be the combination of those elements 1, 2, 3, 4, and 6. The intersection between B and C is simply going to be 6. That's the element contained in both. Then for C, the union of A and B, which is in A, and the intersection with C will be those elements 3 and 6. The universal set is the set consisting of all elements to be considered in the situation. Seven, if A is a set, then A with the little apostrophe is the complement of A. And that is the set of elements in the universe that are not in A. So this is the set of elements in the universe that are not in A. Or in the universal set. And this n of A simply means the number of elements in set A. Okay, let's look at number 9. Probably one of the best ways that I can think of to look at this is to use some sort of diagram. It says in a survey of 70 people, 46 enjoyed comedies, 30 enjoyed documentaries, 38 enjoyed horror flicks, 16 enjoyed both comedies and documentaries, 22 enjoyed both comedies and horror, 20 enjoyed both horror and documentaries, and 12 enjoyed all three. So if we make a Venn diagram of this, where we have the comedies, we'll label that C, documentaries, and the horror flicks, we'll label that H. And this is the universe, which in this case is the number of people surveyed. So N of U is equal to 70. That's the number of people in the universe, so that's the number of people surveyed. When we start looking at this, I would start at the bottom. It said 12 people enjoy all three. So that's the intersection of all three sets. That's going to fall right here. There are 12 people that enjoy all three. Then it says there are 20 people who enjoy both horror and documentaries. So if there are 20 people who enjoy both horror and documentaries, that doesn't mean they don't also enjoy comedies. So that means out of those 20, 12 are already considered. So I have 8 that enjoy horror and documentaries. If I look at 22, or the next one, 22 people enjoy both comedies and horror. So if 22 people enjoy both, we've already considered 12 of them because they like all three. So that means that there are 10 people who like comedies and horrors. And then if you look at the next above, 16 enjoy both comedies and documentaries. Again, 12 are already considered in that overlap. So this would be 4. Now let's go back up. 46 enjoy comedies. Well, of those 46, 10 of them enjoy both comedies and horrors. 12 of them enjoy comedies, horrors, and documentaries. And 4 of them enjoy comedies and documentaries. So that means 46 minus those 26 we've already accounted for in comedies. So that's going to make this 20. Under documentaries, we have 4 that like comedies and documentaries, 12 that like all three, and 8 that like horror and documentaries. If there are 30 in that set, and we have an overlap of 24, that's going to leave 6 people who like just documentaries, who have listed just documentaries. Then in the last category, there are 38 who enjoy horror movies. So that's going to be, I have 30 actually in the combination of comedies, dramas, and horrors. So that's going to leave 8 people who like horror movies or who listed horror movies. A says, how many people surveyed don't enjoy any of the 3? So the universe is 70. If you add up all of the people who like comedies, documentaries, and horrors, there's 30, 40, 50, 64, 65, 66, 67, 68. So 68 people have listed comedies, documentaries, or horrors. So that leaves 2 people who are in the universe who are not in any of those subsets C, D, or H. It says how many people enjoy only horror flicks. So that's going to be only the category that's only H. That would be 8. How many don't enjoy horror or documentaries? That's going to be 2 from the universe, because they didn't list any, and 20 from comedies. So that's going to be 22 people who listed that they didn't enjoy horror movies or documentaries. Okay, if we look at the next two, 10 and 11 are both homework. We'll move on to number 12. We'll talk about 12, 13, 15, and 18 for this video. 12 says, counting formula for sets. If A and B are finite sets, then N, in parentheses AUB, means the number of unique elements when A and B are joined. Okay, and what that looks like is this number of elements in A plus the number of elements in B minus the overlap, the number of elements in that A intersect B, will give me the number of elements in A joined with B. So all we're doing is saying whatever overlap there is between two numbers, we're going to subtract out that overlap so we don't see the same number appearing twice. Number 13, addition principle of counting. If A intersect B is the empty set, then the number of elements in A joined with B is equal to the disjoint set, the number of elements in A, plus the elements in B when the intersection is the empty set. So if the intersection is the empty set, then the number of elements in the union is the disjoint set. The number in A plus the number in B. Because if the union or the intersection is the empty set, there's no overlap there. 14 is homework. 15 says if the number of elements in A is 30, the number of elements in B is 45, the number of elements in the union is 45, we need to find the number in the intersection. So if we go back and look at this, the number in A plus the number in B minus the number in the intersection is equal to the number in the union. So here, 30 plus 40 minus the number that's in the intersection, A intersect B, is equal to what's in the union, which is 45. So I have 70 minus the number in the intersection equal to 45. So that's going to give me that the number in the intersection of A and B is equal to 25. So the number in that intersection is 25. 16 is homework, 17 is homework. Take a look at 18. Let's see. 18 says, in a consumer survey of 500 people, 200 indicated that they would be buying a major appliance within the next month, 150 indicated that they would be buying a car, and 25 said they would purchase both a major appliance and a car. How many will purchase one or the other? How many will purchase neither? So when you look at this, the survey, so the universe is 500. The number in the set who are going to buy an appliance is 200. The number in the set that will buy a new car, the set C, is 150. So when I look at this, I know that 25 indicated they would purchase both an appliance and a car. So if we look at the Venn diagram for this, if this is the appliance, this is the car. 200 people said they would buy a major appliance. Let's start with the overlap. The overlap is 25. So if 200 are going to buy a major appliance and 25 are also going to buy a car, that means that just buying an appliance is going to be 175. Just buying a car, 150 minus 25 is 125. So when I look at this, it says how many will purchase neither. So I have my number in A plus the number in C minus the number in the intersection, A intersect C, is equal to the number in the union of A and C. So the number in A was 200. Number buying a car was 150. Number buying both was 25. And that equals 325. We said there's 150 in the universe. So of the people surveyed, the 500, which is the universe, minus the 325 that indicated they would buy an appliance or a car, that leaves 175 people who will buy neither. So the number of people in the complement of A union C, complement is that little sign, is 175. That means the complement. Those that are in the universe but not in the sets A and C. Now in this video here, number 19 will be homework. Number 19 will be homework. So answer all of the questions that we did not complete on the video for homework. The next video will start with question 20. Thank you.